Welcome to part 4 of the series where we're rewriting a Python Pygame shoot 'em up in Love2D and Monogame. Today is the turn of Monogame in C#. This is the original series that was made by Kids Can Code. I shall put this link in the description. My code is on a GitHub repository here. This is episode 4 with graphics, Love2D, Monogame and Pygame versions. I have not uploaded any of the graphics images. You'll need to follow the links either in the original series or in the link in the comments or even on this GitHub page so that you can download them for yourself. So let's put the window back in and grab hold of it somewhere. Right, there we go. So, Monogame version. I'll just play it so you can see what this one does. It's running in debug mode, which means that we've got rectangles around the graphics. And if I hit the space key, it's currently only firing yellow rectangles. That's so that I could demonstrate what stage we're at without getting killed instantly. So I should be safe now to switch that back to non-debug mode so that you can see how it's supposed to look. So we'll set debug to false and restart it. Now I've discovered that if I've got the window tracked by my mouse, it stops running, so at least I've got a few seconds to get it into place. And I'll release the mouse and start hopefully shooting and moving at the same time. My skills in gaming are complete rubbish. That's why I'd rather code them than play them. But anyway, you get the point. I might just give it one more try. Nope, it even died before I managed to drag it across. Let's try once more. Okay. There we are. No. I'm just not going to bother with this. You can see the principle, and I shall continue to do it in debug mode so that I can show you what's happening. Let's go back and change that. There we go. Good. So let's see how this all works. Now, as before in Monogame, the first thing that works is to load the content. So just check to see whether we have increased the variables. Yes, there's a few new ones now. In the previous video we had these ones up here, which were the basic ones that are required for Monogame. Then we've got a list of mobs and a list of bullets. What we've added now is 4 texture 2D, in other words images. So these are just variables that are going to hold those images. Then we've got the same as we had before, where we've got these bullet timers, intervals and so on to control how often a bullet is fired. So it's really just these images that have been added in. Now when we come down to the load content, this is pretty much the same as it was before. We're initializing the mobs and bullets list. Then we've got this new function called load images. Now with Monogame, getting images in is slightly more complex than it is in both Love2D and Pygame, in that I have a load images function here which I can show you. Custom methods, so we've got load images, here it is. And it appears to be fairly straightforward in that your background image is being populated by this load texture 2D and then the name of the image. But unfortunately you can't just kind of pick that straight off of a file. It has to be pre-processed using this. I can click on the content, this content.mgcb thing here, which is part of the Monogame distribution. If you have not used it before, then you need to make sure it's pointing to the right thing initially. So if I right click on and then go to open with, and it comes up with a list of stuff that you can use, it should be the default MGCB editor down here, and that's the one that we want to use. So if it's not already selected, make sure it is, and then click OK. And then when you double click this, it will, single click it by the looks of it. Let's try that again. But double click it is. Right. We get this kind of dialogue coming up. Now, I've already added my images, which are here. So if you've not already done so, the first thing, if this is the first time you've used it, what you should do initially is to create a new folder. So if I click that, it'll come up with an empty folder, and just name it img for image. And then once you've created the folder, click on it and then go to add existing item. So if I click that, it'll then come up with where do you want to get the items from. Now, depending where you've stored them, yeah, here we go. Find the file that you've stored them in, and then you can select one or more. So you can select them all at once, that's no problem. And then click on open. I'll cancel that. And then these will then appear in the list. Now if I click on any particular one, it shows you how it's going to deal with that image. For the moment we can just kind of accept the defaults that we're using the texture importer Monogame, texture processor, the key color. Just kind of leave all this as it is. We don't really need to worry about it. And then obviously the name of the image there. And so you can change the, if you wanted to, you can change the preprocessors, but for this purpose, just accept them as they are. Once you've finished, hit the save button and then hit the build button here, and that will build the sort of PNG and JPEG and other files that you've got, and put them into this subfolder here. Sorry, where is it? Obj. There we are. There we are. And there we've got, so I can just drag that across. We've got these kind of sub-files that are created by the content importer. And again up here. And these XNB files are the kind of the pipeline, as they call it. These are the images that you have wanting to use, that you've downloaded from file, pre-converted into a format, a binary format that Monogame can make use of. So that's why you use that importer, and that will put them into here. So I've already done this, of course, so those are sitting there now. There are some good tutorials online if you search for them about using the pipeline thing in Monogame, and they'll show you exactly how to do it in far more detail than I've just had. So we'll close that one down. Close that one down. That's it. So we've now got our images are all imported and ready to go. So as you can see, we put them into this load content.load of type texture 2D, and then put in the if it's got a folder as mine has, mine's in the img folder, so don't forget to put that in / then you put the image name, but not the extension, not the file extension. So for example, in our bin folder here we've got XNB. You don't put that in, and you don't put the original image PNG either, so just put its name in. So we've got starfield laser red as you see them here, but without any file extensions. So that's quite important you do that. So that will load the images in their pre-compiled binary format, ready for use. So let's go back to the load content. So we're loading in the images. Now the player, we're creating the player, but this time instead of passing the, I believe it was a couple of sizes we passed before, like an X and Y and width and height coordinate, we're just passing in an image, which is the player image. And then I'm using the scale of 0.5f because the image as supplied is too big. So by scaling it to 0.5, that will halve its scale. And then the speed I've set in here at 300. So that's what we're passing in to create the player. We're giving it the player image at a scale of 0.5 and a speed of 300, both float values there. So let's see how the player deals with that. Right, so this is the constructor of, it is of course a static class, so I shouldn't really call this a constructor because in C# you can have a static constructor. If you don't create one, there is a kind of a built-in one that runs in its place, and that is used the first time you make any reference to the class, to the static class. But I've not deliberately avoided not using a proper static constructor. Instead, I've used this create player method so that you specifically have to call it, which is what we're doing here. So that this is to tie in with what we're doing in Lua and in Pygame, so we're kind of trying to replicate that as much as possible. So the create player, we pass in this player image, the scale and the speed. Those are assigned to the static variables that we have declared at class level here. And then we're creating a rectangle that will surround the image based on the width of and height of the image and the scale, so that we're creating a rectangle that is the same size as the actual image after we have scaled it. That's why I've got the scale figures in here. The height -10 is just so that it sits 10 pixels away from the bottom of the screen. Update is exactly the same as before. The draw is now somewhat more complicated. The rectangle, if you recall, was this one. So we do a sprite batch draw rectangle. We pass it the rectangle and the color. No problem. With the image, you can pass, there's a lot of overloads in the draw function. So this one is one of them. It's sort of about 8th in the list, I think. So what we're passing to the draw function here is the image itself, the position, the source rectangle. I haven't used a source rectangle, so I've put it as null. The color, this would tint the image. So if you put another color in there, it will tint the image by that color. So I've left it at white. Rotation 0. Then again another vector2 for its position. So vector2.0 is 0,0. So I've just used that. The scale we're passing in. Now Sprite Effects, I don't use Sprite Effects in this this shmup game, but you can alter things with the Sprite Effects. So it's something you can look up if you want to. And again, we're not using layer depths either, so you can leave that at 0. So that draws the image, basically. It's fairly complex. Okay, let's go back to main. So we create our player, and then we're then going to create 8 mobs, as we've always done before. This time we're passing the graphics device and the Meteor image, so that we get the image you saw a moment ago. So let's go to the mob, and you can see how that works. So here's the constructor for the mob. So it takes the graphics device and then the image, and again places the image at random places in the top of the window, so that they drop down. So that's not changed, from the last time. So the only thing we have changed is that we're now using an image, and getting the size of the rectangle is defined by the width and height of the image itself. Again, the update is exactly the same. It's the draw function that's changed, so it draws the meteor image. And as you can see with this one, because I'm only drawing the meteor image, I'm not using any scaling, any rotation, anything else there. It's a much simpler draw function. It's just the image, its position, and the tint color, and that's it. And then after that we're drawing the rectangle from it, so that's much simpler. So let's go back to the main one. Then game state set as before, and then at the moment debug is true. I'm going to change that back to false. Actually no, I'll leave it to true, because if I test it out, if I show you again, I want to make sure that I can actually show you something before it disappears off the screen. So that's the load content. We have got, I think, pretty much the same process events is the same as before to get the input from keyboard or controller. The collision checking is exactly the same as before, no changes to that. The mob player collisions, again, no changes to that. So shoot, yep, that's exactly the same as well. So it's really that everything is pretty much the same, apart from the fact that we've now got some images to deal with. So the load content we've been through. Update is exactly the same as before. So it's only the draw that may have changed slightly. No, even that's the same. We've got the player draw and then each bullet's draw, except we're passing, of course, a sprite batch this time only. So that's pretty much it. So that's how this is now dealing not just with rectangles but with actual images. But otherwise it's exactly the same game as you had on episode 3. So we'll just hit that again just to remind you what we're getting. Here's the compiled version running over here. So the collision detection is working the same. Everything else is going as it were, but we've now got this starstruck or starfield background. Let me just show you how that draws. Yes, that's the only thing that I didn't mention. Look, in the draw thing here, we start the sprite batch, begin, and then we draw this background image at a vector 2 of 0, 0, with the white background again. So that draws the background, and then everything else is drawn on top of it. Not too sure whether this clear color dot black is necessary. Let's, just for fun, let's stop clearing it and see what happens. Probably look dreadful. I haven't actually tried this. Oh, it doesn't seem to make any difference. No, so it doesn't look like we need that. I suppose because we're drawing the background image as our first thing and it's covering the whole background, it does the same job. So that's something I've just learned. Okay, so that's C# version of running with graphics.